They go to space to learn the skills to save the Earth and feel the thrills. Brain Voyagers, Brain Voyagers.
Hi, I'm Nathaniel. I'm a student at College of Marin, and I'm working toward the Multimedia Entertainment degree. And in this brief video, I'd like to talk about some of the skills I learned and some of the responsibilities that I had while working on Brain Voyagers. Brain Voyagers is an adaptive learning virtual reality adventure that takes place in space. Adaptive learning is kind of a neat teaching method because not all kids learn in the same way at the same rate. So it takes advantage of strategies tailored to the unique needs of each individual. In terms of the game Brain Voyagers, this means that the game should be appropriate for all skill levels and be able to adjust to be slightly easier for a player who's struggling, and so on. Unfortunately, this is very difficult to implement in code, so what we wound up with really is the basic video game mechanic where you pass the level and the next level is slightly more difficult, or if you're really struggling, you can be demoted to an easier level. We heard about virtual reality in the 90s, but it was sort of in its infancy back then. Now, a couple decades later, the technology has finally caught up to give us an immersive, realistic, and even beautiful experience. The biggest improvements have been in screen resolution and motion tracking technology, which have reduced the queasy feeling some users felt when information from the vestibular system of the inner ear didn't correlate with the visual input they're getting from a VR headset. These days, virtual reality is all over the news, and we're seeing a lot of big money being invested in this industry. From Google, HTC, and Zuckerberg's purchase of the Oculus Rift, many insiders think VR is here to stay.
How would you like me to
The applications for this technology are almost endless. It's not just for games anymore. For example, VR can allow a surgeon to train using a complex and realistic medical simulation, or an architect could do a walkthrough of a building before any construction begins. Practically everybody these days has a VR-capable device in the palm of their hand. But how does this mysterious technology actually work? This was one of the first things, of course, I had to learn in order to make a VR game. Virtual reality immerses you in an experience by showing each eye a slightly different image, essentially tricking your brain into seeing 3 dimensions. Stereo audio can make the immersion even more convincing when used effectively. When I work on a Brain Voyagers scene in Autodesk 3D Studio, I set up a stereo camera rig as follows. Imagine you're in an empty 3D space. First, I place the main camera, which is the one I use when I'm working on the scene. Then I place the stereo cameras, which represent what the end user will see through their left and right eye. The stereo cameras have a child-parent relationship with the main camera. That means I can easily manipulate all 3 cameras just by moving the main camera. The distance between the 2 stereo cameras is called the parallax. When I finish working on my scene, I render out 2 different images, which will be composited side by side. VR viewers have a partition in the center so that your left eye can only see the left camera image and vice versa. When these 2 similar images are processed in our brains, it tricks us into seeing 3 dimensions. Another important skill I had to work on was leadership and my ability to manage a small team. The Brain Voyagers team consisted of 4 guys, including myself, our programmer in Romania, and 2 more local guys, one of which I was fortunate enough to meet in Jeff's game design class. I organized 9 a.m. meetings 4 to 5 days a week to make sure the team was all on the same page, and we would do additional meetings in the evenings since Romania is in a vastly different time zone. We would meet on Skype or sometimes GoToMeeting, which had the advantage of being able to record our meetings. We used Zoho projects to categorize and prioritize the most critical tasks, and I could also assign tasks to the entire team or to a specific member, and set deadlines for the completion of the task. We used Google Drive and Dropbox to share project files with the team, as well as a GitHub repository to manage code. Some of the things that I really enjoyed working on the most were creating textures and animations for Brain Voyagers. Using Photoshop, I created 8 different level textures to give our levels variety. I used a program called Crazy Bump to create bump or normal maps. Normal maps are a great trick because they define how each surface will react to the light. This can really sell the illusion of 3D without adding any additional geometry for the CPU to think about. I also used 3D Studio to design many warp tunnels, which we felt could break up the action and give a cool visual reward for completing levels. Unfortunately, these never made it to the final build of the game. Also in 3D Studio, I animated the nanobots so they come forward and taunt the player to begin each level. I used Voxel Voice Changer to modify my recorded voice to sound like a tiny robot. The audio is important because it gives the timing which I synchronize the animation to. Lastly, I was the lead quality tester. I tested new builds of the game to identify bugs after our programmer implemented any changes or new features. I used screen recordings to make sure everyone was on the same page, especially since English was not Ovid's native language. Bye, thanks for watching.